Hi chemistry students! I wanted to talk to you today about drawing electron dot structures for molecular compounds. They're going to look a little bit different from what we've been doing in the past. In the past we were studying electron dot structures for ionic compounds, and remember that ionic compounds contain a metal in them. And if you take a look in the upper corner of my page here, I drew out a little example just as a refresher of what an electron dot structure for an ionic compound looks like. So here's our metal. We have sodium as our metal, which is Na, and it has one valence electron. Well, sodium is a metal. It wants to lose all of its valence electrons in order to achieve a full valence shell. So it's actually going to give or transfer its valence electron over to my chlorine atom that is adjacent to it. And when that happens, my sodium is going to obtain a positive charge because it lost negative stuff. It lost an electron and now it's positive, while my chlorine, having accepted a negative particle, now has a negative charge. And remember that it is the electrostatic force that is going to bind these two together. Now that was different from what we're going to be doing now. Now we're looking at molecular compounds. Now recall that molecules are compounds that are made up of non-metal elements. And because they are made up of nonmetals, nobody is going to be giving electrons away. Instead, they are going to achieve full valence shells by sharing electrons. So they are going to satisfy the octet rule by sharing electrons with each other. You always start with the electron dot structures for the individual atoms, and then you're going to show that they're sharing electrons with each other by erasing dots and by drawing a dash. And that is what you see here in between my two hydrogen atoms, in between my two chlorine atoms, between my hydrogen and my chlorine. And then look at, we have 3 dashes in between the nitrogen and each hydrogen in the ammonia molecule. So how do we get there? Well, let's take a look first at how to figure out the electron dot structures for each atom. Here I have a little snip of your chem helper, and I wrote down the group numbers above each column. Now remember that the group numbers are going to tell you how many electrons there are in the valence shell of each atom. Now I recognize that hydrogen is all the way over on the left-hand side of the periodic table right here. But hydrogen is going to exhibit properties that are both metallic and non-metallic. And one of the properties of nonmetals that it demonstrates is it shares its one valence electron in order to form compounds. All right, so let's take a look at how to draw the electron dot structure for a molecule of H2. So hydrogen, first of all, on the periodic table is in column 1, so it has 1 valence electron. But since our formula says that we have 2 hydrogens, we need to draw another one. Now remember that hydrogen is kind of an exception to the rule. Hydrogen has only 1 electron in its 1 energy level. It doesn't want 8 electrons. It only wants to gain 1 more in order to complete its valence shell. So how is that going to work? Well, these 2 hydrogens are going to share their electrons with each other. So these electrons are going to spend some of their time around this hydrogen on the left and some of their time around this hydrogen on the right. That's what a covalent bond is. A covalent bond is going to occur when atoms share electrons to achieve a full valence shell. And that sharing of electrons is represented by the dash or by the stick. Let's take a look at another example. Let's do chlorine, which is Cl2. So the first thing that we have to do is find chlorine on our periodic table, and here it is in column number 7. Now let's draw out my 2 chlorine atoms. So here is my first chlorine, and each chlorine will have 7 valence electrons, like so. And each chlorine wants to get 1 more electron in order to have a full valence. So as you take a look at these, you're going to notice that some of my electrons have a partner. See how these are all doubled up? All of the ones that I'm circling here, these are called shared pairs or lone pairs of electrons. These are the electrons that do not participate in bonding. The ones that do participate in bonding are the ones that are alone, the ones that I just put a box around. These electrons are called unpaired electrons. These are the ones that form covalent bonds. So unpaired electrons form covalent bonds. They're the ones that are going to be shared between atoms. So they're the ones that are going to participate. So in the bond. So what we need to do then is redraw our atoms, and we're going to replace our 2 unpaired electrons with a dash. I'm going to erase all of this stuff so that we have a clean slate here. Okay, so I just erased everything. I still have my unpaired electrons in the boxes because those are the ones that we're going to replace with a dash in order to show that they are being shared with each other. So I'm going to redraw my 2 chlorines, and I'm just going to shift my lone pairs around to the outside of chlorine, and then I'm going to replace my boxed unpaired electrons with a dash. And so my final answer, my final electron dot structure for Cl2 or chlorine looks like so. So basically all that you're doing is you're drawing the electron dot structures for atoms, and you're linking up the unpaired electrons with each other. And so far we've only done examples of molecules that have 2 atoms in them, but what about molecules that have more than one? Well, let's take a look at ammonia, which is NH3. So the first thing that I notice when I take a look at this formula is that I have less nitrogens than hydrogen. I have only 1 nitrogen because I have no number over in the little corner. I have no subscript next to nitrogen, but I've got 3 hydrogens. Now, just like in ionic compounds, you're going to place the least abundant atom, the one that you have the least amount of, in the middle, and then the other atoms are going to attach to it. So that's one way that you can kind of figure out how the molecule is supposed to look. So with NH3, we're going to put my nitrogen in the middle, and nitrogen is in group number 5, so we have 5 valence electrons here, and check it out. Because I drew my electron dot diagram correctly, I know that nitrogen has to have 3 covalent bonds. It needs to share its 3 electrons with the other atoms that are in the compound. So now I'm going to draw my 3 hydrogens, and I'm going to put them on the same side as I drew my unpaired electrons for nitrogen. And you can see very easily here that my hydrogen is going to share, these 2 electrons here are going to share, and these 2 electrons are going to share, and those 2 electrons are going to share. And so I just drew some lines real close to those dots, but in order to make it perfect, and yes, I will take off for this on a test and a quiz, you've got to get rid of the dots. And this is your final answer for a molecule of ammonia. Sometimes, however, you're going to have atoms that are going to share electrons, maybe not just in a single bond, but in a double bond. Ooh, and I think I feel like I erased that a little bit prematurely, so let me just redraw my ammonia there. And this is not perfect, so let me get it perfect. Okay, so as you can see, we have 1 dash in between this H and my central atom, my nitrogen. This is called a single covalent bond. This 1 dash means that you have 2 electrons being shared. So in each dash, you have 2 electrons being shared. What this means then is, since my hydrogen has this dash attached to it, it has 2 electrons around it. This hydrogen has a dash attached to it. It has 2 electrons around it, which is exactly what hydrogen wants. And the same with this one. But if we take a look at our nitrogen, it has 3 dashes. Remember, each dash represents 2 electrons, so that means that nitrogen has 6 electrons incorporated in the dashes, but don't forget our lone pair that it has. That means that my nitrogen has 8 electrons all around it. It has a full valence shell, which was the whole purpose in the first place, right? Remember that nonmetal atoms are going to share electrons with other nonmetal atoms in order to achieve a full valence. Okay, so I just wanted to make sure that I talked to you about that. But there are some molecules where the atoms are not going to make just single bonds. They might have to make more bonds with the atoms that they are adjacent to. So let's take a look at oxygen, which has the chemical formula O2. That means that I have 2 oxygens next to each other. Since my oxygen is in column 6, each oxygen has 6 valence electrons. And again, I have to impress upon you, it's important to follow the upside downside pattern when you're drawing these. Okay, so each oxygen has 2 unpaired electrons, and they can't stay that way. They need to participate in a bond. So if these 2 are shared and those 2 are shared, that means that I can have 2 covalent bonds between my 2 oxygens. What's going to form is something called a double covalent bond. And here's how it looks in my final drawing. Let's draw my oxygens again, but I'm just going to shift it so that my dots And you could draw this with the dots top and bottom, or you could draw these, you know, side and bottom. That would be fine too. Something like that. The important part is coming up right now, though, because now we have to create our double covalent bond. So we're going to draw a line or a dash to show the sharing of our first 2 unpaired electrons. And I'm going to draw a second dash to show the sharing of my second pair of unpaired electrons. And now they're paired. So let's take a look. I'm just going to draw a box around this oxygen. I have 2 bonds that are connected to it. So remember, I've got 2 bonds, and each bond represents 2 electrons. So that is 4 electrons. And then I have 4 paired electrons. And when I add them all up, that means that the oxygen that I have my box around has 8 valence electrons. The same is true for my other oxygen here. I have 2 electrons in each bond, so that makes 4 electrons. 5, 6, 7, 8. So each of my oxygens has 8 valence electrons. And I am done. So this is my electron dot structure for oxygen. Now guess what? Sometimes you're going to have atoms that are going to require a triple covalent bond. So let's take a look at P2. So P is in column number 5, which means that each phosphorus is going to have 5 valence electrons. Whoops. Sorry. So my lone pairs are going to stick together, but what if I shared those 2 and those 2 and those 2? You can see that I have 1, 2, 3 connections between my 2 phosphorus atoms, and if I redraw this, I'm just going to include my 3 connections in the middle. And I can't forget to add my lone pairs at the top of each phosphorus. So now if I take a look at the phosphorus on the left, I have 2, 4, 6 electrons represented by my dashes, and plus 2 more gives me 8 valence electrons. So that means that my first phosphorus is happy. And if I look at the phosphorus on the right, I've got the same thing. 2, 4, 6 electrons in the dashes, plus 2 more at the top also gives me 8 electrons around that phosphorus. And this is your final drawing for P2. This is called a triple covalent bond. All right, chemistry students, I hope that you found this helpful. I will talk to you in class. Bye.